Okay, so good morning again, everyone. We are beginning from what you did last time. All right, so if you recall with your session with Miss Louise, you went through the second transformation, which was reflection. She showed you how to do the reflection over a mirror line. Now, if we recall carefully, reflections are what we say what we describe as a flip. So you would notice that the object and the image, they will be on two sides of your mirror line. All right, and it looks as if they flipped over. Okay, so that is how we can be sure that when we look at a transformation, that it is a reflection. What if we notice that from the object to the image, it looked like it slid? What type of transformation do we think that would have been? Anybody can answer?
Um, um, it's an FT.
Yes.
Translators. I don't know.
Translation. Very good. Good
Translation.
attempt. Yeah, translation. So the translation would be a slide and the reflection would be a flip. Okay. Now with Miss Dorini, you met with different mirror lines. You met the y-axis, right? That is the vertical line on your Cartesian plane. When you draw your grid and you do your X, your Y, and your origin, we know the Y-axis is the vertical line, the one going up or down, right? And then we met the X-axis, that would be your horizontal line, right? From left to right, right to left. Okay, and then you met the line Y equals X, and that would be a diagonal line. It would be going from what direction, what end to what end? Anybody can tell me? The line y equals x. Nobody recalls? Okay, so that one would be going from the right to the left. So the diagonal will be going um, from the positive side on the x-axis to the negative side on the x-axis. So it will be going in this direction. All right, whereas the other one, the line y equals negative x, would be going the other direction. So it will be starting from the negative side on the x-axis to the positive side on the x-axis. All right. So, okay, so with that said, we also did other mirror lines. And other mirror lines mean that the line can be anywhere on the grid. So for example, in your homework, that's what we have up on the screen here. On your homework, you had to do the line y equals 2. And it means that you had to look at the y-axis, right? And the y-axis again is the vertical line. So you had to look at the y-axis, you had to look for the positive 2. And wherever you found that positive 2, you would draw a line through it. So your line would actually end up going through that 2 on the y-axis. And the same thing applies for the line x equals negative 2. You will look for negative 2 on the x-axis and you will draw a line through it. Okay? All right, guys. So did you do your homework? That's the question.
Yes, Miss, they went through the homework with us in the last class.
Also, she went through all of it with you?
Yes, Miss.
Okay. So do you have any questions on it?
No, miss.
Anybody have any more questions when you went over it? You saw something that you didn't understand and you want us to go through quickly before we go to what we're doing today?
You go through time it sounds in there.
Or you're not there? Okay.
No.
All right. So the pink one here is the original. That's the object, right? And remember when you're doing your reflections, ensure that you label your shapes. So you label your object. And since this was a reflection over the y-axis, it means your y-axis is your mirror line. So when we say it's your mirror line, we mean that is the line you're going to flip over. Okay, so like I said, the y-axis is the vertical line. That's this one here, right? Are you seeing my cursor?
Yes, miss.
Okay, so that's the y-axis. And so since that is the y-axis, for us to get our answer, we had to say for this point here at the top here. All right, so for this point here, how far is it from the mirror line? And if you check the boxes we have here on our grid, you would see it's one box away, right?
Yes, miss.
So that means to get your image, then you would have to count the same one box away from the mirror line. So that is why your answer ended up being here. So you started off with this triangle and you had to find out this what the image was. That's this here, that's the answer. So let's do another point. What about here? How many boxes away was this point here from our mirror line? So you would count
Miss 8 or
1,
7.
2,
Miss
3,
6.
4, 5, 6. Good. And
6.
because it is 6 away from the mirror line, on the other side of the mirror line, you have to count the same 6. So you would say 1, 2, 3, 4, 5, 6. And this is where you would plot your image points. Okay, this would be the reflection of this point here. And let's do the third point here. So again, remember to label them so you'll not be saying first, second, third point. You would be saying A, B, or C, or X, Y, or Z, or whatever it's labeled as. So this point here at the bottom, again, you see how far away it is from your mirror line. So we're counting 1, 2, 3. And so on the other side, we must also count the same 3. So that would
Yes,
be
miss.
1, 2, 3. When you have your 3 points plotted, then you draw your line and you form the shape. You draw the lines to form the shape. All right. Now let's look at the second one here. In this case here, you don't have the same mirror line. It tells you the reflection is over the x-axis. So since the reflection is over the x-axis, it means your mirror line is not vertical. It is horizontal. So in that case, you look at your object. That one at the top here is our object, right? The one that looks purple. And we are trying to get our image, which would be the blue one. Now it's done for you already, but we're just reviewing how we went about getting the answer. All right, so you start off with any one of the points. So in our case here, I'm going to start off with the points at the top. So I'm counting how many spaces. In our case, we can see them as boxes away from the mirror line. So if you are having a problem remembering not to count this one as 1, you can always start at 0. So you can say 0 where you start, and then 1, 2, 3, 4, 5, 6, 7, 8. You see I meet my mirror line? So when I meet my mirror line, I notice that I have 8 spaces. Did someone have a question?
No, miss.
Okay. So we are doing the same 8 spaces away from that mirror line to get our image. So 1, 2, 3, 4, 5, 6, 7, 8. And you see that's why they stopped here and they plotted here as the image point for this one, for the object point up here. You do the same thing for all of them. If you notice this 1, 2 away, and the image will be the same 1, 2 away from the mirror line. The object here is 1, 2, 3, 4 spaces away, and this one will be the same 4 spaces away. What do you think will be your challenge here in doing a reflection? What would be a challenge here? Anybody? Also far in doing your homework, what were the challenges that you encountered? Was it finding the mirror line? Anybody had problems finding the mirror line?
No, miss.
Okay, so everybody knows where the y-axis is, where the x-axis is. What about counting the spaces? Did anyone had problems counting the spaces?
No, miss. No, no.
Okay, so that means reflection is fairly easy for everybody. Yes? All right, let's do that these two, and then if you still have any questions, then we will go to the final two for your homework. If not, then we'll move on to what we have to do today, which is still reflection, but reflections using matrices. All right, so let's look at this one here. Again, you started with the blue shape. The blue shape here, the blue triangle is your object. Okay, now you see they crossed over each other, but you don't make that confuse you. You stay focused on counting the spaces away from the mirror line and counting the same spaces to get your image on the other side of the mirror line. So let's look at let's start with the points at the top here. So how many spaces away from our mirror line is that point? Okay, so let's go 1, 2, 3, 4, 5, 6, 7. Right, guys? And so to get the image, you have to go on the other side of the mirror line. So you would go this way. So 1, 2, 3, 4, 5, 6, 7. And you see how they got the answer? Let me do that one again. So we're starting with the point at the top here. So we're counting 1, 2, 3, 4, 5, 6, 7. We met our mirror line. Now from here, you have to go on the other side. Now some persons may make an error and decide to continue going straight, right? But if you continue going straight, you will notice that if you were to fold on the mirror line, your your object and your image will not touch each other. And that's a little thing that you can do for you to ensure that your answer is correct. Once you once you fold on your mirror line, your two corresponding points, your image and your object, your A prime and your A should be able to touch each other. Now imagine folding this one here on that line. So you take that paper, imagine that's a paper, and we are folding it on the mirror line. So the mirror line will be our fold. Do you notice that these two are going to meet? They're going to touch each other?
No, miss.
You don't see that they're going to touch each other? No? All right, so what we have to do, we have to probably do it on actual paper for you to see. Fold it on the mirror line and you will notice that they will actually touch each other. And that's how you actually know that a reflection did happen, your reflection is correct. Okay, because it's supposed to be exactly the same distance away from the mirror line. All right, so when you have a chance, take the homework you did and fold it on your mirror line. And then you will tell me if the object and the image points met. Okay, anybody have theirs with them right now to try it out? The homework?
Okay, miss.
Nobody? Okay, well, if you don't have it right now, we'll do it another time. All right, guys, so remind me though, so we won't forget. So in that case here, we do the same thing for each point. So this one here is one space away from the mirror line. So on the other side of the mirror line, we go one space up. This one here, it is 2 spaces away from the mirror line. So we go 2 spaces on the side here, on the other side of our mirror line. Okay. All right. Now, you also have the shortcut method, which is at the bottom here. Remember that if you have a point, for you to know too that your point is correct, if you have x, y, so let's say 5, 4, you expect your image to be 4, 5. So if you have 5, 4, your answer will be 4, 5. So it will seem as if they switch positions. That's a shortcut to ensure that your answer is also correct. Okay, let's go for this one quickly. 1, 2, 3, 4, 5, 6, 7, 8, 9. and on the other side of the mirror line would be going downwards. So you go the same 9 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9. You see how they got their answer? So again, here this point, 1, 2, 3. You don't stop on the y-axis. It's not your mirror line. You continue. 4, 5. And you reach your mirror line. Now you go on the other side of it. Means that you have to go downwards. 1, 2, 3, 4, 5. And that's how they got the image. Again, for this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then to get the image, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, guys, so it will be the same thing for this line here, where you have a line that is not the x-axis or the y-axis. You have any line, so they could have given you y equals 5. How do you get the line? Remember, if they tell you y equals 2, you look for 2 on the y-axis, and you draw a line through it. Okay, and you can see here they do the same thing. They count the spaces away from the mirror line, and then they find the same number of spaces to get the image away from the mirror line on the other side. This one here, you notice that the point was on the mirror line, so the image will also be on the mirror line. So it had no spaces away. So the object had no spaces away, the image will have no spaces away as well. All right, guys, so that's a quick revision on what Miss Louise did with you last class. Do you have any more questions before I move on?
Miss question, that's a revision of Miss Louise class or
Yes,
not?
that's a revision of what Miss Louise did last class.
Okay, because I missed it. I woke up late.
Oh, okay. So what Miss Louise also has a video posted on the Form 5 Google Classroom. She recorded it with Zoom, the same thing I'm doing right now. So what you can do is, if you don't fully understand what I've done in the revision, you can look at what she has posted on the classroom. But do you understand how to get the mirror line?
Yes, I do.
And do you understand how to count the spaces between the mirror line and the object?
Yes, I do.
And do you understand that you have to count the same spaces away from the mirror line on the other side to
Excuse
get the
me.
image?
Yes, I do.
Well, you know how to do a reflection now.
Excuse me, miss.
Yes?
Miss, how you getting the mirror line again?
Which one? The mirror line that's not the y-axis and the x-axis?
Yes, miss.
Okay, so for example here, y equals 2. So if the mirror line is y equals 2, you look on the y-axis line, that's this line here, right?
Yeah.
You look for 2, because it said y was equal to 2. So if you notice, that's 0, so here will be 1, 2. When you get the 2, you draw a line through it. And that's how you get that mirror line.
Oh, okay. Thank you.
So if they told you y equals 5, you would say 1, 2, 3, 4, 5, and you draw a line through this. So this would be your mirror line.
Okay.
Yes, and the same thing for x. You look on the x, if they tell you x equals -2, like Miss has here, you look for -2 on the x-axis, and you draw a
Yeah.
line through it.
Yes, miss.
Yes. Okay. All right, guys. Any more questions for us to move on? Okay, I take that as no more questions. All right, so today what we're doing is today we are doing reflections still, but we are learning how to do reflections using matrices. Okay, now like I told you when we did translations, the translation transformation, it uses a vector. So you add the vector to the object and you can get your image. All right. Or you can subtract the vector from the image to get get the object. With reflections now, you don't use vectors, you use matrices. You also use matrices with the next set of transformations that you will meet, and they are rotations and dilations or enlargements. Okay, so today I'm going to take you through how to do reflections using matrices. Okay, so just hold on, let me share the new screen with you. Are you seeing what I'm showing you here? Are you seeing reflection using matrices?
Yes, Miss.
Great. So, all right, so quick revision again. Reflections, they are transformations that occur using a mirror line. They flip over the mirror line. So it is a flip over a mirror line. The object and the image are congruent, meaning that the object and the image are going to look exactly the same. The object will not be small and then the image end up being large, or one of them is like a regular size shape and the other one looks squeezed. They will end up looking exactly the same shape, same size, same everything. Okay, the only thing that changes is that one will flip over, so you will notice that across the mirror line that it will be pointing in opposite directions because it flipped over. All right, the object and the image are the same distance away from the mirror line. Okay, that's our quick revision. Now we are going to learn how to reflect objects using matrices. So we're not using the grid anymore. You still have to know that information. That's why we started with it. But you have to also know how to reflect your objects using matrices. How? See the question here? How? One, you will represent the object point as a column matrix. So it will be looking like a vector. So it will look like when you have the x and the x on top and the y at the bottom. This is how it's going to look. So you first take your point and you ensure that it looks like oh, okay, sorry guys. Okay, it's not allowing me to draw. Okay, so I'm not allowing me to draw, so that's okay, I guess. Let's go back. Okay, so you have to first represent the point as a column matrix. Secondly, you have to multiply the correct matrix by the column vector or the column matrix that you have. It will appear, well, it's basically a vector really and truly, and also a column matrix because it has the X on the top and the Y at the bottom. All right, so I really wanted to demonstrate to you what do I mean by represent the object point as a column matrix, but this is not allowing me to edit it. So I will show you in the example in a while. Okay, in our previous slide, I said multiply the correct matrix. So at one time you will be telling yourself the correct matrix. That means there are several matrices. Yes, you are correct. If you were thinking that, there are several matrices and the matrices all represent a different mirror line. Because remember, reflections are transformations that occur over a mirror line. So these are the different matrices for your different reflections based on the mirror line that they tell you. So if you have a reflection about the x-axis, this is the matrix that you will be using. If you have a reflection about the y-axis, this is the matrix that you will be using, and so on. Y equals x, that's it. Y equals negative x, that's it. Or a reflection about the origin, this will be it. All right, guys. Now, you may be saying, it's a lot to remember. If you look at it carefully, you will see patterns. And also, when you multiply the matrix by the points, you will also notice the same shortcut method that Miss Louise must have mentioned to you, when you will notice if it's X and Y based on the mirror line, whether it will seem to switch or whether you see one of them become negative or not. you will notice that happening as well. So for that, in case you use a wrong matrix, you say, oh no, my answer couldn't be that looking like that, you know. So therefore, you can go back and try out a different matrix. Now look at it carefully. If you notice, this one is 1, 0, 0, -1. Notice the -1 is at the bottom. This one is the same ones and zeros, but then the -1 is at the top. That's for Y. Yeah? All right, so and then this one here though, you see that it doesn't start with the 1, 0, 0, 1 like the others. It starts with 0, 1, 1, 0. So with practice 2, you'll end up remembering what they are. Okay. If you know too, remember when we wrote we changed our equations to when we did simultaneous equations and we changed them to matrix form. Notice how we did it, where we put our x's and where we put our y's. You would notice that if you were also writing a point as a matrix, this will be your x and this will be your y's, right? If you write it as a single column matrix, the top number here would be your x and the bottom number would be your y. Now also you know that with a reflection in the x-axis, you would expect your x's to stay the same, or would you expect them to change? Somebody?
May I say that again?
If you have a reflection in the x-axis, do you expect your x values to change or would it stay the same?
Stay the same.
Right, to stay the same. And that's why you can, if you look at the matrix, you can see that the x is 1, meaning that the value would stay the same. And what happens to the y at the bottom here? It is -1, so we expect whatever y value we have would become negative. Okay? Now, how do you use these matrices to perform a reflection? How? You use what you know already, which is matrix multiplication. You have to multiply the matrix for the reflection by the point. And remember, we write the point as a column matrix. So, example 1. All right, so example 1 here. We have this reflection occurring here. It's done for you already, but we are analyzing it so we can understand fully what's going on. So you have 0.22, right? And then you want to get what your image is, which is A prime. They told you that it's a reflection in the y-axis. Okay, and your image also here, the picture I have here, you can see clearly that the flip was over the y-axis. This is the y-axis. This is the object, this is the image, and so the flip is over this y-axis. So we know our reflection is in the y-axis. What do? We use the transformation matrix for reflection in the y-axis. This is the correct transformation here for the y-axis. The -1 is first, 0, 0, 1. You always pre-multiply, meaning that you always put the matrix for the reflection or any transformation first, and then you put the points. So notice, guys, I had this point here written as we normally write points as coordinates, x and then comma y. And notice to do the working, what happened? I changed it to the column matrix here, or it looks like a vector, right? So instead of having them next to each other, I have them now on top of each other. So I put the x on the top and the y would be at the bottom. Are you following me so far? Anyone is confused? Let me know.
No, miss.
I understand.
Miss me.
You are confused? Okay,
Yeah.
so I'm starting again. It's a reflection in the y-axis. So you have your points. Ignore this image here. Ignore it for a bit. This is what we're starting with. This is our object. So you are trying to find out what is the image. Your object here, we're starting with A, is 2, 2. So because they told you it's a reflection in the y-axis, you are going to use the matrix for the y-axis reflection. Let me go back. Remember, every reflection have its own matrix. So reflection in the y-axis, this is it. The one with -1 first, and then 0, 0, 1. So notice that I use that same matrix here, -1 first, 0, 0, 1. And then I put it first, meaning that I'm pre-multiplying. I put the matrix first for the reflection, and thereafter I put the point. Now notice I didn't write the point next to each other like this. I put it in as a column matrix so that we can easily multiply it as we would with matrices. Are you clear? Is it clearer now?
Yes, Miss.
Yes, Miss.
All right, now remember when we are multiplying matrices, it is, somebody tell me, how do we multiply matrices?
Row by column.
Row by column, very good. So our row by column, so that's -1 times 2 plus 0 times 2. You see the answer I have up here? Then you do the second one, you say 0 times 2 plus 1 times 2. Row by column. I'm doing it again. So for the top, -1 times 2 plus 0 times 2. Then we use our,
Question.
go ahead.
Will they be giving us the object and the image, or we have to? Will they be giving us the
No,
object and the image, or we have to find it?
they'll be
Find the
giving
image.
you the object,
We have to
and
find the
I'm showing you
image.
how you find your image. You
Oh,
find your
okay.
image by multiplying the matrix for the reflection by the object. So notice
Oh, okay.
here, you see our answer here end up being -1 times 2 is -2 plus 0 times 2 is 0. So that means your answer is -2. Watch it, observe it. And let's look at the bottom. 0 times
Yes.
2 is 0 plus
Miss,
1 times 2 is 2. Yes?
there's a quick way I found it. The x icon in that number will just be a negative.
Yes, but I'm showing you all how to work it out if they ask you to show how to work it out using matrices. Because if they ask you to work out something using matrices, then you have to be able, you have to show you're working. So I'm showing you how you would work it out. We know the shortcut method because you've already done reflection before, and also Ms. Louise went over reflection again if you're in the previous session, right? So she showed you the shortcut. She showed you that if it's in the y-axis, then the y's will remain the same and the x's, the sign will seem to change. That's a shortcut method. But today I'm showing you how you would work it out if you had to work it out using matrices. All right, because that's an objective on your CXC syllabus that you should know how to work it with matrices. So if you
Okay,
have
miss.
to, yes. So if you have to work it out with matrices, you have your object and you are trying to find your image, you would multiply the matrix for that transformation by the object, and it should give you the image. So notice here, that's why I have the working out here. Notice that at the ending, you end up with -2, 2, which is what you expected to get because we did it already here. So you see how the answer is -2, 2, and that's the same answer you got here. So right now, I want everybody to try out this one here. Multiply this same, notice I'm using the same matrix because it's the same reflection in the y-axis, but now I'm multiplying that matrix by the other point. So I'm using B now. So I would like you to do that for me. Multiply that matrix by the 4, 4, and tell me if you will get the -4, 4. Go ahead, I'm giving you 2 minutes to do so. And people, please do the working for true.
Yeah, miss, I got it.
Okay, guys. So did you get the negative 4, 4?
Yes, miss.
Yes. Okay. So for the 5, 1 as well. Okay. Some persons also did the 1 for 5, 1. Very good. So that is how you
Yeah,
go about working out reflections with matrices. All right. So let's do another example because our time is almost up. This one here now, sorry. Oh no, before we go to the next example, this is another way you can work this out. If you do not want to do the working where you have to do each point, you can actually take all your points and make them into one matrix. So notice this, the first column here, that's A. Do you notice that's the 2 and the 2 from A, guys?
Miss.
Yes,
All
I
right,
see
and
it.
the notice B, that's 4 and 4, that's B here. And this
Yes.
one here is C, the 5 and the 1. What you can do if you prefer and you do not want to do the working 3 times, you can actually work it out all at once. So let's try it out. Everybody have their papers and their pens out.
Yes, miss.
Okay,
Yes,
so
miss.
we're
Yes,
working it
miss.
out using 1 multiplication instead of doing the 3 multiplications. So it will be negative 1 times 2. I want to be able to write for you all to see. So, but this is not allowing me to edit it. So what I'm going to do, just allow me to share it with you in a different place. I will share it with you on my browser instead. If it allows me to do that too. Okay. I just want to do that 1 multiplication with you, and then the rest you'll have to try them out for your homework. No. All right. Sorry about that. Okay, guys. So I'm going to share it here. I'm going to share it with you from my browser instead. So I believe that it will allow me to edit now. Can you see the screen?
Yes, miss.
Okay, so let's do the working quickly, right? You see it's allowing me to edit now. So that will be a big multiplication because remember that you have a matrix. Oh, sorry. Okay, so remember it is your row by your column. So let's multiply. Some persons, I hope you have started. So that's negative 1 by 2 plus 0 by 2. Yeah, so that's the top.
Yes, miss.
Okay, I'm going to box it so that it doesn't confuse me when I do the rest. So then -1 by 4 plus 0 by 4. All right, so I finished with the second column. I'm going to box it too, just to make sure they don't mix up the numbers here. And then the last one, the same -1 row by column by 5 plus 0 by 1. Okay, and that's here. How do we get the bottom, people?
0 times 2.
You have to do
0
what?
by 2
Use
plus.
the second one. Very good. I'll do the same color here. So to be 0 by 2 plus 2, sorry, plus 1 by 2. Then 0 by 4 plus 1 by 4. And then the same 0 by 5 plus 1 by 1. All right, so row by column. I'll box it again as well. So based on what we're seeing here, since we have
Miss, that's working.
which one?
That one, that's long.
You find it's longer than doing each point?
Yes, yes, Miss.
Okay. Well, to each its own. Everybody will have something they prefer. Somebody else might actually find it's one working. So, but I have to still show you all the ways to work it out. Okay. All right. So that will be -2 plus 0. So that's -2. And that's the x. Remember, these are your x's, the top, and your bottoms will be your y's for your different points. Right? And remember, that's a. That will be a prime, because that's a here. All right, that's b here. And then that's c here. All right, so this one here, the bottom would be what? 2? Yeah, because 0 plus 1 times 2 is 2. That one is -4 plus 0. So that's -4. The bottom here is 0 times 4, that's 0, plus 1 times 4, that's 4. Here, that's -1 times 5, that's -5, plus 0, so that's -5. The bottom is 0 times 5, that's 0, plus 1 times 1, that's 1. And look at your 3 points. You see them, people? This is A prime. This is B prime. And this is C prime.
I see it. It's easier, but there's a lot of work in it.
Yes, it has a good bit of work because you're multiplying. All right, so but this is how it's done. If you do not want to do the two matrices or the multiplication at once, you can do it the first way I showed you, which is multiplying the matrix by each point. So each point, you still get the same answer. Remember, in math, there are several ways to work out any sum. All right, the same way here, that this is an example with the y-axis. Notice that we do not use the same matrix. You notice that, people? Why did we not use the same matrix? Can someone tell me?
Miss, what you say?
Why didn't we use the same matrix? I'm hearing the answer.
Because that's not the identity. No.
Because that's not the matrix for that reflection.
Yes,
Okay? Every reflection have its own matrix based on the mirror line. So in that case here, our mirror line is the x-axis because it went over the x-axis. So you use the matrix for the x-axis. You multiply it, and when you do so, you're supposed to get the answer here. So let's just do a quick multiplication and then we'll end the session. So 1 times -2 rho. Let me think box the row for you to. Oh no. Oh no. Okay. So row by column. Okay, so 1 times -2 plus 0 times 1. That's our top. That's our x value. And our bottom, use the bottom row, 0 times -2. Plus -1 times 1. Okay, and let's do this quickly, the working. So negative, that's -2 plus 0, so that's -2. And that's 0 plus, that's -1.
-1.
Right. And can you see that we got the same answer that they had when they did it using the graph?
Yes,
Same
miss.
-2, -1, right? So the matrix works. And what you're going to do thereafter, you would apply that same matrix to each of the points, or you can do it this way, where you put all the points as one matrix. Remember, the top values are your x's for each point, and your bottom values are your y's for each point. So this will be A, B, and C. And then when you get your answer, you'll get A prime, B prime, C prime. All right. It also works for these two guys. So if you have a reflection here, for those who are having problems counting, you
Please
can
go
use.
back. I didn't finish writing it yet.
Okay.
Okay, you can change it now.
All right, no problem. All right, so even for here, guys, this is the matrix you use. Again, you take each of the points. So -4, 2, right? And you multiply it by your matrix. You do it for each point, or like I said, you can do your whole thing. You can do the whole thing. Can someone tell me how to do the whole thing? So let me make sure everybody knows how to do it if they want to do the whole thing at once. What would be here if you want to do everything at once?
-4, 2.
4, and then at the bottom 2.
-3, -1.
-3, -1.
And
-5,
-5,
-2.
-2.
Right, -5 and -2. And then you work it out as one whole thing. All right. When you work it out, if you decide to do it, remember it's row by column. So that row here, you multiply it by this to get the top. The top row gives you the top value. So this row here is giving you your x's. And then when you're done, you use the second row here to give you the bottom values would be your y's. All right. So that is how you do reflections with matrices. Do you have any questions for me?
Please go back. Let me see it again. Yeah, I understand. But you have to do it for each point though.
Okay, so whichever method you prefer, like I said, you can go ahead and use that method. All right, now for our homework, I'm giving you you have two of them to do for me. I'm going to post the PowerPoint. So this one here, I put the matrix that you're supposed to use here for it. All right, as time goes by, you will learn your matrices by heart. So the question one says, what are the coordinates for A, B, and C? What are the coordinates for A prime, B prime, and C prime? Using matrices, show how A, B, C is transformed to A prime, B prime, C prime after this reflection. All right, so this is a reflection in which axis? This is a reflection in which axis, guys?
Miss X.
X. Very good. So for your homework, what I basically want you to do for me after you find the coordinates is to show me by multiplying the matrix for the reflection by the points of the object that you can get the image points. That's what I want you to show me. So that's this one, and also you have this one, which is a line y equals negative x. So it says, given that the coordinates of the triangle ABC are these, use matrices to find A prime, B prime, and C prime. So that means you have to show your working on how
Okay.
you would do it. And remember, we always put the reflection matrix first. We always pre-multiply. We put it first and then we put the points or the points. Okay, guys? All right, does anyone have any questions for me before we end?
No,
Can you
miss.
go to the previous page?
You go pardon?
Can you go to the previous page? Let me write
No
down the
problem.
homework. Yeah.
Okay, but then you would have to still I would post it on the Google Classroom though, because you would have to still look at it for a bit to write down the points, the coordinates for A, B, and C.
You say take out the picture.
Oh, okay, all right, no problem.
Hmm.
Tell me when you want me to go to the next slide. In the meantime, anybody has any questions for me? All right, so for us to wrap up, can one person tell me how exactly we can reflect an object using matrices in their own words?
May I say that again?
Can someone tell me how they would reflect an object to get the image using matrices in your own words?
Okay, Miss. First thing I would do is like I would write the reflection down, like if it's over the x-axis, y-axis, or whatever. Then I would write down one of the point. I would write down the points, and then I'll solve for the points. And then from there, I'll just plot it on the other side. I'd count the spaces away from the mirror line and just plot it then.
Okay. All right, good. Anyone, so what you basically said is that you would first you get the matrix for the reflection and then multiply it by the points to get the answer for the image. Yeah?
Yes, I would. And then I'll just check the mirror line and stuff to make sure all of it is accurate.
And you would still check it over to make sure it's accurate using the mirror line by counting. Okay, no problem. Good contribution. Anybody else wants to give us a summary and then we'll just end?
No. Nothing.
Nobody else wants to give a summary before we end? Okay, so okay. All right, guys. So thanks for being here. I hope everyone learned something new today. All right, and then that same concept of multiplying the matrix by the points is what's going to be used when you do matrices with the other transformations. So that's why I want you to practice doing it. So then whatever other matrix that you get for whatever other transformation, it will be a breeze. So you just apply it and you'll be able to get your points. And sometimes these questions come up where you are probably in a multiple choice exam where you don't have the graph paper or the grid, all right? And then you just have to find what the points are. Or sometimes it may even ask you which of the following matrices represents a reflection in the y-axis or a reflection in the x-axis. Remember that the values at the top of the matrix in the first row, all right, they will be affecting the x values, and the values at the bottom will be affecting the y values. So with that said, you know that for the x-axis reflection, then for your matrix will always be, the x-axis matrix will always be positive at the top because we know our x's stay the same in the x-axis reflection. But with a y-axis reflection, the x's will change and the y's will be the same. So that way we expect that with a y-axis reflection, the matrix will look such that the top now would be negative and the bottom number would be positive. So that's little things that can help us remember or identify the correct matrix. Okay, spend some time also trying to learn them and do the homework. I'll post it for you up right now. Guys, have a wonderful day. Bye-bye.
Bye-bye, Miss.
Yes,
You,
Have
miss.
a nice
I
You too
miss.
as well.
A
Thank
great
you.
day.